Hello everyone. So today I will be going to discuss to you or elaborate to you a topic which is soil and water conservation. So in this report I am with Miss Jane Parahinog, which is later on she also have a topic to be discussed. So now let's talk about soil and water conservation. Tropical soils are open to erosion agents. The water and wind due to overgrazing, deforestation, and inappropriate methods of crop production that result to reduction of the degraded land. So, controlling runoff and thus preventing soil erosion, reducing soil compaction, and maintaining or improving soil fertility are the most common reason for using soil and water conservation measures. So that's all about soil and water conservation. And now let's move on to water and wind erosion defined. Erosion either by water or wind is the washing away of the topsoil from a piece of land. It causes a lot of damage to farmlands such as listed below. So first is erosion. First remove the topsoil. Topsoil afford the best root environment by providing the best structure and most air and an inactive population of the living organism such as topsoil is the lost, only less productive subsoil remains. Next will be the topsoil contains most of the soil's organic matter and plant nutrients. Erosion carries away nitrogen, phosphorus, and any nutrients stored mostly in organic matter. And next is the third one will, as erosion strips away the soil surface, the profile becomes thinner, decreasing the root zone. This is a particular problem on already shallow soils. The major effect of this shrinking root zone is reduced value of total water holding capacity. And next is gullies cut filled into odd-shaped pieces and make it very difficult to operate farm equipment. So generally, liquid water, wind and ice causes the majority of erosion. Usually in the form of glacier, erosion occurs when the muddy or the glacial ice is muddy. The brown color suggests that the rock and soil particles are suspended in the fluid, air or water being transferred into the location to another. So, next topic will be types of soil erosion. A raindrop strikes the soil surface forcefully. The impact shatters soil aggregates and throws soil grains into the air. On a slope, water begins to flow downhill carrying detached soil grains with it. This water joins other flowing water increasing in speed, volume, and soil carrying capacity. This other of events leads into 5 of erosion. All 5 types of erosion occurs in the same times in any given slope. So these are the 5 types of erosion. So splash erosion. This is the direct movement of soil by splashing. A soil grain can be thrown as far as 5 feet by raindrop splash. These splash particles filled the voids between other aggregates and seal the surface. Next will be sheet erosion. This is a removal of the thin layer of the soil in a sheet. On gentle slopes or near and the tops of steeper slopes, water moves in tiny stream too small to be noticed. This gives the impression of losing soil in a thin sheet. Sheet erosion may go unnoticed until the subsoil appears. Next, rill erosion is visible as a series of many small channels on a slope. Water tends to collect channel, picking up energy as it runs down the slope. As a result, running water carves out small but visible channels called rills. A rill is small enough to filled in by tillage. And next will be ephemeral gillies are large rills. The channels is small enough that tillage equipment can cross it and largely but not completely fill it by tillage. During another heavy rainfall, water will collect in and all channel and erosion will begin here. Gilly erosion. The most highly visible erosion. Gillies are also large equipment cannot cross them. Gillies usually begin to form near the bottom of a slope on a steep slope where running water is enough force to carve a deep channel. Gilly heads may back uphill as water running into guy collapses the site. So generally, water erosion or splash erosion, sheet erosion, rill erosion, and gilly erosion are the four types of soil erosion caused by rain. The effect of falling raindrop, which can be scatter small soil particles as far as is known as flash erosion. Rill erosion is that occurs when runoff separates into individual stream or rills. So that was all about water. That was all about splash erosion. And next topic will be the universal soil loss equation. The universal soil loss equation was developed to predict the average soil loss from sheet and rill erosion on any specific site. The USLE or the Universal Soil Loss Equation also helped the farmer to adopt the most economic soil preservation measure. The USLE is based on the standard test plot which represent an average eroded site. This plot is 9% slope, 2.6 feet long. And the equation will be A is equals to RKLSCP. A stands for is the tons of soil lost per acre each year. Obviously, A should be less than T to solve for A. Values are inserted for the 6 variables and are multiplied. The variables are R stands for rainfall and runoff factor. Is based on the total erosive power of storms during the average year. R depends on the weather condition. The isoredent map shows R values are the country or region. Next one will be K. K stands for soil erodibility factor. K depends on textile structure and organic matter content. Soil survey reports give the value of K for map soils. They may also calculated. Next will be LS, slope factor. L compares the slope length and S compares the grade with the standard plot. L and S are compares factors, but they can also be treated as one variables. LS or LS values can be determined from the chart. And next one will be C, covered and management factor. C compares cropping practices, residue management, and soil cover to the standard clean fallow plot. C values are calculated from detailed tables and valid only within the area for which they are calculated. Many SC offices prepared simplified tables for use in the field. and some have computerized and computations. And lastly is P stands for support practice factor. P compares the effect of the contour tillage, contour strip cropping and terracing with the test plot, and LS factor account for terraces primarily, but they are included this because they are contoured. Based on the rainfall patterns, soil type, topography, crop system, and management practices, the universal soil loss equation as generalized predicts a long-term average annual rate of erosion and field slope due to changing weather conditions. They are erosion values expressed by these components and can be changed significantly. Next topic will be the factors in wind erosion. Soil erodibility relates mainly to texture and structure. Soil in high fine sand are most liable to wind erosion. Soil roughness makes a large still air layer at the soil surface, each cold and ridge also like a tiny windbreak to slow the wind and to capture blowing soil. Climate conditions that promote wind erosion include low rainfall, low humidity, high temperatures, and high winds. Dry windy conditions cause faster soil drying, and dry soil is more erodible than moist soil. Dry soil also support a thinner vegetative cover. Length of field affects erosion. On the leading edge of the field, there is no wind erosion. As the wind travels across the field, it picks up more and more soil grains like an avalanche. Vegetative cover protects the soil, and thus a mulch bare soil, on the other hand, is fully exposed to the erosive force of wind. So generally, atmospheric precipitation, wind, air temperature, air humidity, and solar radiation are the main climatic factors that influence erosion processes in a specific area. Atmospheric precipitation, water erosion, and wind are the two variables that have direct impact of the soil wind erosion. So that's all about my part, and next part will be tackled by Miss Jane Parahinog. So that's it. Thank you for listening.
Hello everyone. So today our topic is about agronomic practices for control of soil erosion in water and wind. So among the different methods of erosion control, agronomic practices are considered effective and are usually given precedence because they are less expensive and deal directly with reducing raindrop impact, increasing infiltration, reducing runoff volume, and decreasing wind and water velocities. It is also easy to fit them into existing farming systems. So agronomic practices used in erosion control includes the maintenance of high soil fertility, which means continuous maintenance of ground cover in addition to high organic matter helps to conserve soil and prevent erosion. It is believed that wise use of fertilizers, lime, and manure increase the fertility of the soil, which enhances proper plant growth, leading to bumper harvest and an insurance for maximum ground cover. Next is Mulching. Mulching protects the soil surface from the different impact of raindrops. The raindrop on bare soil tends to break soil aggregates apart and produce a crust of puddled soil. Such crusts have low permeability that reduce infiltration and increase runoff. Maintenance of cover, like the use of mulching materials, at all times reduces crust formation, increases permeability, and consequently there will be little runoff and erosion. This is one of the major crop management practices used in the control of soil erosion. Next is crop rotation. Crop rotation helps to maintain a better soil condition to absorb water. When grass legume crops are included in crop rotations, then the continuous monoculture farming. Crop rotation is a systematic sequence of planting one crop after another. In addition to ensuring quick and efficient ground cover, legumes have abundant vegetative growth, which provides large quantity of crop residue to protect the soil surface, in addition to enriching the fertility of the soil. Now we have the next, contour tillage. Contour tillage is the cultivation of a sloppy small piece of land with ridges made across the slope rather than along the down. Contour farming is adopted on a sloppy land, and it is mainly done to reduce soil, water, and nutrient loss. If done properly, it serves as an obstruction to flow of water down the slope. Such restricted water subsequently infiltrates into the soil, thus minimizing runoff and erosion. Next, we have strip cropping. Strip cropping is used on a sloppy land also, just like contour tillage. In this case, the entire field is divided into a series of strips separated by uncultivated bands. The system is called contour strip cropping when the strips are laid out on the contour. This crop is grown in which alternate with the strips of grass. This is the example of legume. This is the main strip right here on the first, this one. Okay, sorry. And this is here the maize strip slope. Now we have fallowing. Fallowing is an age-long method of protecting the soil from physical, chemical, and biological degradation. This is the practice of abandoning a piece of land to regain its fertility status, after which it is now used again for another period of cropping. Soil fertility maintenance is through the long fallow period. A fallow period is the number of years a piece of land that had been under cropping is allowed to revert forest. Fallowing is a means of storing water in the soil from one year to the next, protects the soil from erosion, and helps to restore soil fertility. Now, the next after fallowing is alley cropping. Alley cropping, a promising system developed over the last several years, consists of growing rows of food crops between deep-rooted trees. The trees are pruned or pollarded at regular intervals to control shade and to produce mulch materials that are spread on the cultivated land between the rows. Where this is practiced, this association of plants has maintained excellent continuous productivity and fertility maintenance. Leguminous tree crops are preferred because they can tap atmospheric nitrogen into the cropping system. In alley creeping, both the fallow and the cropping period are integrated at the same time. In addition to erosion control, this system has an added advantage of recycling soil nutrients, more especially if legumes, shrubs are used. The last is minimum tillage. Minimum tillage is the conventional tillage operations of ploughing. Harrowing and ridging usually lead to increased soil compaction, which eventually reduce infiltration and encourage runoff or flood and erosion. Minimum tillage system eliminates all tillage operations except planting and has the following advantages, which is reducing the rate of erosion and conserves water due to surface cover of plant residues. Reduces the cost of production and increases crop yield. Now our next topic is about appraisal of shifting and continuous cultivation in Nigeria. Now what is shifting cultivation? Shifting cultivation is a cropping system whereby a piece of farmland under forest is opened up and used for cropping for 2 or more years before moving to another site. The fresh land under forest or bush is cleared by the slash and burn method, which involves the cutting down and burning the existence of vegetation. The system comprises a cropping period when food crops are produced for a few years until there is nutrient depletion, reduction in yields, and infestation of weeds. The piece of farmland is then abandoned for a fallow period for the regrowth of the vegetation and the rejuvenation of the soil fertility. There is usually a yearly or biannual movement for one piece of land to another. Now, shifting cultivation is also the practice that had been carried out over a wide variety of soils, over 30% of total worldwide arable land. Now we have importance of the fallow period. Now what are these? These are the restoration of fertility lost during the cropping period. If the cropping period had not been too long, the fallow period may be enough to restore the fertility. It is otherwise may be necessary to apply chemical fertilizer. Closed cycle is established under a forest canopy. Nutrients pass from soil to vegetation and back to the soil. The second one is suppression of weeds. The land may be abandoned due to invasion of weeds. The emerging vegetation and trees during fallow help to suppress weeds in addition to recycling nutrients from deep in the profile. The third one is high level of organic matter is maintained by the large returns from the vegetation in form of litter and timer fall. The roots help to bind the soils, thus increasing infiltration, minimizing runoff and erosion. The fourth one is diseases and pests are controlled by fallow. Fallow may deprive insect pests their host plants, thus starving them and reducing their population. Now, what happens when vegetation is removed or during burning? The answer of that is clearing of vegetation causes the closed nutrient cycle to be broken. There is an initial flush of nutrients due to increased mineralization of organic matter, especially under tropical conditions. Burning provides ashes to raise the soil pH, but there is loss of nitrogen, sulfur, CO2, and other harmful products which add to the global warming process. Apart from N and S which escape the atmosphere during burning, other nutrients remain in the ash and are present as carbonates and phosphates such as K2CO3, K3, PO4, and CaCO2, MgCO3, which react with soil acids, which is alkaline effect. This is to raise the soil pH. The direct heating effect of burning in soil may serve to kill undesirable soil pests and weeds, but the interest is to see much of the organic matter return to soil without burning. Through burning and high oxidation, organic matter content of the soil declines sharply and soil structures deteriorates under impact of rainstorm and lack of fauna activity. Now for conclusion, water erosion removes the topsoil, reduces yields and deposits in streams, lakes, and reservoirs. Wind also strips the topsoil, blows away the smallest soil particles, and buries ditches and other structures. Because falling raindrops and running water detach soil particles from the soil surface and carry them away. Depending on the slope, erosion removes soil as a sheet or creates rills and gullies. Water erosion is promoted by bare and erodible soil, long or steep slopes, and lack of conservation particles. Soil scientists is the use of the universal soil loss equation to compute soil loss. The USLE accounts only for losses from sheet and rill erosion and will understate soil loss where there is ephemeral or gully erosion. Using the USLE, a specialist can suggest practices to keep a farm productive. Growing vigorous crops, maintaining organic matter, and avoiding over-tillage and compaction help to control erosion. Both conservation, tillage, and crop rotation sharply curb erosion. Contour tillage, contour strip cropping, and terraces are effective ways to slow runoff. Where these are not enough to stop runoff, they may be combined with grass waterways or outlets to carry the excess off the field without erosion. And again, everyone, good day. This is Miss Jane J. Prahanog and Miss Devian S. Peringas, my partner, and we are your today's reporter. Thank you.